All right, so welcome to our Monday office hour. I'm excited we got two people here. Usually it seems like it's one or four, I don't know. But so what questions do you guys have?
With me, I was just wondering, I've noticed on a couple lessons, and that particularly lesson 9, like the, I guess the preparation assignment, the video, I mean the answer sheet compared to what the video where he goes over the problems had different answers. And I didn't know, yeah, and the way it came out was the guy on the video was accurate and the preparation answer sheet was not.
We need to fix that. Yeah, if you'll let me know what's wrong, what's inaccurate, I will make sure that gets fixed.
Okay.
Glad to hear the video it's easier to fix the answer key than the video, but
I'm assuming the video's right because even sorry for my dog. I'm assuming can you hear her? I hope not.
Oh, it's not, it's all right.
I'm sorry. Anyway, yeah, because we both, even my group, we agreed. So I'm gonna.
Okay. Yeah, what if you can point that out, just send me an email and I will check that out and I will get that fixed if the answer key is wrong. So
okay.
I swear we find all the errors, but you guys are good at finding them even on the weekend. So
yeah, and even in the booklet one time there was an answer that was different than I received. I think it was also lesson 9.
Yeah, I know sometimes they change things, but we try to stay on top of it, but not always. So
well, the reason I asked that is because how do we know when we're doing an exam where we're going to come up with an answer and it may be 0.1 off, that we're going to be marked wrong? How does that work?
So as a general rule, they try to take into account rounding errors.
Okay.
And so usually if you're 0.01 off, that won't be a big deal. But if you're 0.1 off, that might be a big deal. So
okay.
Yeah, that's why if there's a problem on the homework, we want to make sure you're doing it properly. So the other thing that I will say as a general rule is if I always tell people don't round until the very end. So don't round z-scores, don't round anything until you finally get your p-value, and then at that point you can round.
Okay.
So all right, well, what other questions?
My question for today is I've started reading the material for this week, and I'm a little confused in the sample size and that whole formula. I get the confidence interval formula, I get all that, but then when you go to the sample size formula and figuring out, you know, the margin of error without a mean per se, you're trying to figure out all of that, then I'm a little confused.
Is this in lesson 9 or lesson 10?
I think it's 10.
10, okay,
10.
so
yeah, lesson 10.
Sample size calculations. Let me see if I can share that here so we make sure we understand here. All right, so so here's your sample size formula, and so n equals z times sigma over m. Now,
It's right there.
So typically, when you're figuring out, like in real life, you can set your margin of error to be anything that you're comfortable with. So that's just a number you kind of make up out of thin air. If you want to be within, 3% margin of error or whatever, you can make that up to whatever it is. Now, in the class, they will say, okay, so what should your sample size be given 95% confidence and a margin of error of 6 or whatever. But really, this m here, this margin of error, it's whatever you as the study author want it to be.
Okay.
So, but usually when we're doing this, because we don't want you to come up with 5 different answers, we'll say, okay, assume margin of error is, 6 or 3 or 4 or whatever it is. So they'll usually tell you.
Okay.
Any other questions?
Nope.
So we're going to be given mostly the margin of error. So will we be needing to use the m equals the z over sigma over the square root of n in our exams?
So do you see this formula that I've got highlighted here?
Yeah, I see that one, but it's before that.
Oh, you're asking something different?
Yeah. Because
she's asking on the confidence level.
Oh, so I think I know what you're asking now. Now, typically, so there's a couple ways to do this, and I think this is the answer that I can give you. So one of the things that I don't like about this book is it kind of hides some formulas from you. So do I not have this open? So typically, so we've got a spreadsheet here. Okay, so for example, so if it asks you for the margin of error, so this is your data here that you've got here. You've got your confidence level, you can put in your null hypothesis and type of test, and then you've got your confidence level here. So a lot of times they will ask you what is the margin of error. So there are actually a few different ways to find that. Probably the easiest way is to just take this plus this, and then divided by 2. Okay, so that should be your mean. That's your point estimate. Notice, actually, I guess I could have done that. That's exactly the same as that number there. So one way you could figure your margin of error, well, there's a few different ways, is you can take the high minus the mean. That gives you your margin of error. Or you could take the mean minus the low. Or you could take the upper minus the lower and divide by 2. That gives you, well, that's not rounded there, but yeah, that also works. Now, since you mentioned the formula, so this is your formula. So this piece of the formula right here, that's what you were talking about. That is actually the margin of error. Yes, that's correct.
Oh, I see. Okay.
Now and it's the same thing as this piece here. So you're adding and subtracting the margin of error.
Oh, okay.
So if you wanted to figure that out by yourself, so they ask you what the Z star is. So it depends a little bit on so that's not on this page, although they give you the 95% confidence interval. So if you wanted, you could go to the applet. And so with a 95% confidence level, you want the middle to be highlighted there. And so you want this to be 0.95. 0.95. And so that gives you a Z-score of 1.96. Okay? So what you can do is you can take that 1.96, as I go back to the book here. So this Z star is 1.96 now, and then you can take your sigma divided by your square root of n, and that's a 4th way of figuring this out. So if I take 1.96 times my standard deviation, oh, now that's a little bit of a problem because I don't know what the standard deviation is. Now, I can guess, but this is not a this is a t-test, not a z-test.
Oh, okay, that's true.
So my number is going to be off a little bit because that's not the true standard deviation, but it should be pretty close. Divided by the square root of my n, in this case, is 6. So this is going to be off, but it's going to be pretty close. Oh, it's actually off more than I thought. And the reason why is because this standard deviation is not correct. That's the sample standard deviation, not the population. So, and obviously I don't know what the population standard deviation is. Now, another thing that I want to mention here, as we go to the online book here, if I go back to the main page and I go to quantitative data. So you've got both of these, lesson 9 and 10, are Z-score, where the population is known. Population sigma is known. On Thursday, we're going to do it where sigma is unknown. That's going to be a T distribution, which is the spreadsheet. Now, one of the big problems here is a lot of times people they say, oh, I see the standard deviation here, I can use it. No, when it says sigma known here, you're assuming you know the population standard deviation. If you don't know the population standard deviation, that's your sigma unknown. And you can see that off the spreadsheet, which in this case is 5.492. But notice this is for a t-test.
Mm-hmm.
So one of the biggest mistakes that people do on the test, the next test coming up, and I know we just had a test, is they say, oh, it's a one sample, I can just plug this in the spreadsheet. And you should not. You should only plug it in the spreadsheet if your population standard deviation is unknown. That will get, so if it asks for a confidence interval and they give you the sigma, so I don't know what the sigma would be. Well, actually I could probably figure it out, but then you should not use the spreadsheet.
Okay.
Because your answer will be, notice how when I did these three, if this represented the population standard deviation, I should have gotten the same answer, but I did not. It just gives me a smaller margin of error.
Okay.
Okay. So so that's that.
Okay.
So
Okay.
so just make sure. And one of the problems is especially with Unit 2. We're going to teach you how to do hypothesis test sigma known, a confidence interval sigma known, and then we're going to do both the confidence interval and the hypothesis test for sigma unknown. Then we're going to do it for paired data. Then we're going to do it for independent data, and then we're going to do an ANOVA test. Okay, so what happens is in this class, in lesson 9, you always know, well, this is the formula I use. And in lesson 10, this is the formula I use. And in lesson 11, this is the formula I use. And then you get to the review and you're like, well, I don't know which formula to use. You didn't tell me. And I'm telling you, you need to make sure that you know the requirements for all of these tests so that, for example, you don't pick the confidence interval. You pick a z-test when your sigma is known, and you pick a t-test when your sigma is unknown. Does that make sense?
Mm-hmm.
So confidence intervals and hypothesis tests are basically two different ways to do the same thing. They're very different methods, and basically we're going to start throwing them all together. You'll notice here with the spreadsheet, I've got the one sample t-test. You've got your hypothesis information here, and actually here. And then you've got your confidence interval here. And so you've got that with your paired t-test, the confidence interval, and your null hypothesis stuff. Sorry, I didn't mean to highlight that. Same thing here, your p-values, your confidence intervals, your ANOVA, your f-scores, your p-values, and then we won't do linear regression on this test. But so you've got basically 4, plus you've got a z-test, and the z-test is where you should figure the confidence interval with the formula, not with the spreadsheet.
Okay. Well, in lesson 11, which I started because our group meets Wednesday morning, and I noticed sometimes I review the videos before I really get into actually reading the lesson. And I think this time may have been a mistake because when I was listening to the video, the example that he used when he was figuring the sample t-test, he used the SPSS on his video, And that kind
Oh,
of
he
threw
did?
me. Yeah, it kind of threw me. He said it's the same in the Excel. So I
Oh,
pulled up the one sample t-test for the means. I guess my question, and I may answer it when I go to the paper version, do you have to, before you fill, before the the t-score is put in or there, because it gives you the t-score in the homework reading. Do you have to know all the summary statistics first before you populate your variable? Because it has you pull up the body temperature, and I did that, and I thought, well, I may have messed things up because I kind of may have done it backwards because I put in the z-score, the t-score first.
so I'm not following you what you
Yeah.
mean.
Okay.
Is this in the lesson itself?
Yeah, lesson 11.
Okay, so body temperatures, let's look at this. Okay, so we're going to apply the t-distribution as we explored. So the hypothesis test is conducted in a similar manner where the sigma is known except for the population standard deviation. Can't see. We're going to use S. So this leads to a t-distribution.
So S is the t-distribution, right? Okay.
Yeah, and so that's going to be one of my big things here is I'm going to, oops, I clicked the wrong one. And it's a bummer. We used to use SPSS a lot more than we use. Oops, I still can't seem to grab the right one here. Oh, here we go. Than we do now. It used to be 221B and C used to use SPSS, and it was really expensive program, and so now everybody's using Excel now. So they kind of need to update the videos. But at any rate, so the hypothesis test is mu equals 98.6 versus mu does not equal 98.6. Okay, so because it's a not equal to, that's going to make it a two-sided test. We're using alpha of 0.05. So if we go ahead and we take this file here, body temperature, so I'll download that, and then I'll go back to where we were. So it's asking you to give the relevant summary statistics. So if I go here to body temperature, and I say, okay, so I'm going to copy all this information. This is for males and females. Okay, so this is my file. I'm going to go over here. It's a one sample t-test. I don't know the population standard deviation, so I'm going to paste it. My null hypothesis should be 98.6. My confidence, because it says my alpha is 0.05 right here.
Okay.
So that means I've got 95% confidence. My null hypothesis, it says it's a not equal to right there.
Right.
I need to change this to a not equal to. Okay.
Okay.
Now, so it's asking you what are the summary statistics, and it gives you the answer there. So you can see that your mean is 98.23. Your S is 0.738 standard deviation. So that's your sample standard deviation, not your population standard deviation. And your N is 148. So you can see, whoops, you can see all three of those are right there.
Okay, so it looks like because when you populated the variable, it did put in the 6.029, the minus 6.029. Because when I first did it, I didn't have it populated. I put it in myself because I was following the video and I got confused. So
oh yeah, you should never change that. That's whatever it is. Now, having said that, a lot of times people forget to put in the null hypothesis. So if I left that back at 10, notice my t-score is really very different.
Okay, that helps me. Okay, so you populate first.
Okay, yeah. So yeah, you put your data there.
Okay.
So, all right. So as we go through this, so there's your histogram that looks roughly normal. Says X bar should be normally distributed because the sample size is large. Now, remember, so here's one of the things, and I'm going to really try to emphasize this. Just so with the central limit theorem, one of the things that we typically say is so long as your sample size is larger than 30, it is often, but not always, normally distributed. Now, technically, we should probably take this information and we should put it in our histogram maker.
Mm-hmm.
And that's
The other guy.
right here. Yeah, the other guy here, which is right here. So my histogram maker, I paste it, and that looks roughly pretty normal. Okay. Now, a lot of times we skip that step and we say, oh, and so it's important to know 30 is not a magic number.
Mm-hmm.
We should always be checking to make sure our data are normally distributed. We could also do the QQ plot. I paste it here. Now, if that was my data, would that look normally distributed?
No.
No, not at all. But it does say I need to sort my data.
Right.
And when I sort my data, now it looks very normal because
Mm-hmm.
it follows the line.
One thing, Brother Bennett, I noticed I was working on homework or something. If you go back to the histogram,
Mm-hmm.
and I noticed and I think it was homework, that mine did not match what the answer was. And I thought, okay, what's the deal? And what I realized is I needed to increase the number of bins.
Yeah, so they use SPSS. That's why it looks like this. How many bins do they have? 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18,
Oh.
19, 20, 21, 22, 23, 24. I think that's what they're using.
Wow.
We're only using 5. But if I go to 24, now it looks like that one.
Yeah, okay. That's what I noticed by trial and error, that if I increased the number of bins, sometimes it did match better and I understood it better.
Right. So, yeah. So, and in fact, it doesn't look exactly the same one if I go 25. Now it looks more, does it look closer? No, I don't know. Because SPS, yeah, the problem is it's never going to look exactly the same.
Oh, but I got a better feeling for it.
Yeah, it's better feeling, so.
Okay. Thank you.
All right, and so one of the things I remember, and let's see if I can find this, just to prove the point about just because your data are not 100, let me see if I can find this. I have a worksheet that I use in my UVU class, if I can find it. And the problem is I don't remember. I hope it's this one. Oh, well, this is not the one I was looking for, but it'll probably work. So let me erase all this data here. Actually, that's not 30. Well, I need one that's larger than 30. I need to label these so I know what they are. Maybe it's this one. I don't think that's it either, but this is, how big is that?
33.
Oh, that's 30 exactly. I have a feeling
Oh, it's 30.
that this one's not going to be normally distributed, but maybe I'm wrong. Oh, I should have erased all that. Now, I probably don't want 25 bins if I've got 30 of them because that'll never work. Well, that's a little bit skewed.
Mm-hmm.
Well, I guess that's kind of, I know there's another one. The problem is I don't remember.
What if you made it like 10 bins? Would it change the skew?
Well, if you put too many bins, then
No.
Yeah, that kind of looks a little bimodal.
Okay.
Let's see here. I know there's one. The problem is I don't know what it is. When do I teach QQ plots in my other class? I don't remember. No, that's not it. Anyway, well, here, tell you what. I can do something here. If I do random numbers, come here. So I'm just going to do a random numbers equals rand between 1 and 100. Okay. And I'm going to do 100 of them, or I don't know, 140. Okay. Now, does that look normally distributed to you?
No.
No, it shouldn't. Those are random numbers. Those are evenly distributed. So once again, what I want to point out is my n in this case is, does it not give me my n? No, well, it's like 140 or something. It's way bigger than 30, but my histogram does not look normal.
Mm-hmm.
And in fact, let me copy this. If I were to paste it here, get rid of these on here because they don't belong. And if I sort this, oh, that looks more normal than I expected, but you can see that this is kind of curvy.
Mm-hmm.
See, that should cause you some concern to say, I don't know if my data are normal. And this is way larger than 30, okay?
Mm-hmm.
So 30 is not a magic number. That's the point I just want to make sure. You should still look at your histogram and make sure that your data are normal. But it often works when your sample size is 30 or more.
Okay.
Okay. All right. Any other questions?
I don't think so. I'm good so far.
Okay.
I just have trouble with I'm okay with the math part. It's just remembering the definition type things is where I get thrown, but
Oh, yeah.
I have the same trouble with scriptures. Sometimes I don't understand them correctly, but
Yeah.
I'm getting there.
Yeah. Especially that Old Testament stuff, that can be pretty tough. All right. So if you guys don't have any questions, then there's one of two things we can do. One of the things that I love to do, although it's a little bit early, is I love to go through some scenarios, and then I can say how you decide if it's a t-test or a z-test or an f-test or a chi-square test. Now you've only learned the z-test, so like I said, it's a little bit early, although I can kind of get you guys looking at that if you want. So that's one thing we could do. It's a little bit unfair because you guys have no experience at all doing this, so you'll probably get it wrong. But it would give you an idea onto what do you look for in a problem. Or number two, I know, Jackie, you'd like to go over your test, so we could end the meeting now and I could go over your test, so that's an option. I'll let you guys choose what you want to do.
I'll leave that up to Carrie.
I think if you jump ahead, it's just going to confuse.
Yeah.
Where all we know right now is z-score.
Mm-hmm.
I'm afraid that unless you can tell me, no, it'll make it crystal clear. Then I say, if it'll make it crystal clear, let's review that. But if it's just going to confuse, I probably would prefer waiting until the appropriate time.
Okay, that's fine. That's fine. Like I said, it's early, and it's actually hard for me to be like, okay, so this one matches your homework really well. Because usually they don't.
Okay.
Are we gonna ever use the t-applet? I noticed there's a second applet.
That is a really good question, and I'm glad you mentioned that because that will actually be in Thursday's lesson. So, yeah, let's mention that really quickly. So, if you go to course resources, you've got your T probability applet. So this will be used on Thursday's lesson. Notice this looks very similar, and it works very similar to the normal probability applet. I can put in 1.5 here. I can change my degrees of freedom to be 7. I can change this to be 0.95, that sort of a thing. So this is in fact, you can kind of compare it to the normal curve just by clicking that. As your n gets larger, say 70, you'll notice that there's not much difference between it and the normal curve.
Mm.
But when your degrees of freedom are small, like 2, then there's a significant difference. So the t-distribution is a little fatter in the tails, a little skinnier towards the peak, especially with smaller degrees of freedom. But this works very similarly to the videos. Now, the one thing, they made these videos before this app existed. And I know that in one of the videos, he says, because this didn't exist when he made the video, oh, I'm not really supposed to be using the T, so I'm going to use the Z, but you should use the T. So anyway, it's really cool. The funniest thing about this is, like, when you go into the lesson, I'm pretty sure, not this one, it's in lesson 11, because they do kind of mention it to you.
Mm-hmm. Yeah, I've started it.
Oh, see the click here, like nobody ever clicks on that thing. That will take you to the T-applet.
Mm-hmm.
It took me like a year before I said, you know what? Because I didn't, the funniest thing, I had a student, he goes, what is this T-applet? And I'm like, what are you talking about? He goes, green. I'm like, what? He showed it to me and I was like, oh, that's cool. I didn't know we had that. And it took me, seriously, it was almost a year before I was like, that really needs to be in the course resources. And so now it's there.
Yeah.
And so you should always use the T when it asks for a T, and you should always use the Z when it asks for a Z. And it can be confusing, but the difference is, once again, I will re-emphasize this, and I'm going to emphasize it every week from every office hour from now on. If you know your sigma, is it a Z or a T?
Z.
It's a Z. If you don't know your sigma,
T.
It's a T, yes. So just drill that into your head, like that's a big important rule. And so when you're doing your scenarios, here's one scenario that I'll give you a preview. We'll do this maybe next time. But when you're scanning through here, one of the good things to do is to say, okay, what do I know? Is there a mu? Is there an X bar? Is there an S? Is there a sigma? Is there an N? And so a lot of times you can write all that down and you can say mu equals whatever it equals, an X bar equals, if you know it, an S and sigma.
Right.
If you write all this stuff down and then you can say, oh, well, if I know my sigma, it's a Z. And if I don't know my sigma and I know my S, it is a T. Because you can always find your sample standard deviation because you collected it, right? You may not know the population. So so that's your T versus your Z in a nutshell.
Okay.
So I'll save that for Thursday's lesson. and we'll go over something like this.
Okay.
And say how you decide. So just as I said before, you know, basically we spend 2 lessons doing hypothesis tests and confidence intervals, and then we'll throw them both into this one. And we'll throw them both in for everyone. And so once you get down to about the 2 that are most easily confused are the paired data versus the independent samples. Easily the most confused. You won't mess up ANOVA until we get to unit 3, and then you'll be like, oh, ANOVA and chi-square test of independence, those are kind of similar.
Wow.
So you'll get those 2 confused too. Usually these are pretty simple, although sometimes people mess those up, 1 versus 2. But yeah, and then the sigma known versus sigma unknown, a lot of times people will plug it in a spreadsheet when you should not plug it into the spreadsheet.
So the known you can, the unknown you shouldn't.
Correct.
Okay.
Actually, vice versa.
Vice versa.
The unknown, plug it in the spreadsheet. The known, you should calculate it yourself.
That's right. Okay.
So I'm glad you asked me about that T-distribution applet. That's a good thing to go over. So they added that about 1.5 years ago, I think it was, and I was like, this is way cool. So, all right, anything else?
Nope, I'm good.
I'm good too.
Okay.
So I'm going to drop off.
All right.
We'll keep this a nice short meeting, and I will post this as soon as I can, whenever it gets done compiling. So.
Okay. Thank you.
See y'all.
Nice to meet you, Carrie.
You too, Jackie.
Bye.